What is the best evidence we have that there is intelligent life out there in the universe? The truth is that there is no evidence at all there is intelligent life in the universe other than our own. Now, with that in mind, we can still speculate and make educated guesses about whether or not life is out there. There is an estimated 300 billion stars in the Milky Way galaxy, which would support the claim of a statistical probability there is intelligent life in our galaxy and universe. Some people feel the Drake equation would suggest there are thousands of civilized cultures in our galaxy at any given time. While scientists think life, in and of itself, is common, they do not believe intelligent life is as common as one might hope. While it is statistically likely there are more models for life than we are aware of, scientists think it's safe to use our own planet as a template for the environment for intelligent life. As far as Drake's equation goes, the biggest issue with it is the average number of planets that can potentially support life per star and the number of planets that are capable of producing intelligent life, which are both part of the equation. For years, it seemed like the only requirement for intelligent life was a planet existing within a star's habitable zone, and for that planet to have water. But over the last 20 years, we have learned that might be an extremely simplistic view of the situation in our universe. Red dwarf stars make up as much as 70% of the stars in the Milky Way galaxy. The compositions and nature of these small stars make them extremely volatile, with their light dimming as much as 40% at times, as well as throwing off a great number of solar flares. Since these stars are much smaller than our Sun, they would also be much cooler than our Sun. This means their habitable zone is much smaller, and any planet existing within it would orbit much closer than the distance the Earth orbits the Sun. Any planet that would exist with any habitable zone on a red dwarf would most likely wind up in a tidal lock, with a single side facing the star, and most likely become baked out like Venus. So when applying this to Drake's equation, the number of viable stars that can be included in it is greatly diminished, and eliminate as many as 210 billion stars as potential candidates. There are other factors affecting star formation on both the outskirts and interior of our galaxy that might preclude them from being viable candidates as well. It is speculated that stars on the outskirts of the galaxy do not produce enough heavy metals to create viable planets with environments conducive to life. The galactic interior is estimated to have an abundance of radiation, which could also hinder the formation of intelligent life. It's now been found that a habitable zone is not limited to just the solar system, but can be found within galaxies as well. The Drake equation might need to be reworked to include this. So it would seem that there is a habitable zone not only within a solar system, but within a galaxy as well, and using 300 billion stars as part of Drake's equation might not be accurate. Scientists' second biggest criticism of the Drake's equation is with estimates of the number of planets that are capable of producing intelligent life. While it has been discovered life and of itself can exist in extremely harsh environments, that's no indication intelligent, advanced life forms can. If we look at the Earth, we really have a perfect environment when compared to planets in our solar system. Over the last 10 to 15 years, we have learned our planet is special on top of being comprised of over 70% water and location in the Sun's habitability zone. It has a molten spinning core that creates a magnetosphere that protects us from harmful radiation, which protects our atmosphere from being blown away by solar winds, unlike what happened to the Martian atmosphere. Our planet is also volcanically active, and plate tectonics help recycle nutrients into the soil and air. It also has an ozone which helps protect the surface from harmful ultraviolet light. Many of the reasons we have a perfect planet is because of the moon. Current belief on the formation of the moon is that in our early solar system, a planet approximately the size of Mars, named Theia, collided with a moonless proto-Earth. The collision destroyed all of Theia and much of the surface of proto-Earth. After the collision, parts of the two planets merged, but the remaining debris orbiting the post-collision Earth coalesced into the moon. The survival of the Earth colliding with another planet, and then to go on to create the perfect environment for intelligent life, is likely very rare according to astronomers. It is speculated that this caused the Earth to start rotating on its axis at its current pace of 24 hours a cycle. After the moon was formed, its effects on the Earth is most evident in the form of strong tidal waves in the oceans. Less evident is the effect the size of the moon has on the Earth's seasonal tilt. The Earth-Moon size relationship is the greatest in our solar system, with no other planet having a moon as large as ours. The moon is approximately 25% of the size of the Earth, and some classify it as a double planet. The size helps stabilize the seasonal tilt as we orbit the sun. Without it, our planet would shift much more on its axis, creating much more severe weather patterns. One last thing to mention is that there have existed other species of intelligent Homo sapiens such as Homo sapiens neanderthalensis and Homo habilis, but ours is the only one to have survived. So being intelligent, in and of itself, is no guarantee of survival. Another discouraging fact is that it took 4.5 billion years for intelligent life to evolve on Earth. That's almost a third of the age of the Milky Way galaxy itself. One last argument against the commonplace of intelligent life in our galaxy is the question, where are they? If Drake's equation is correct and the Milky Way galaxy has thousands of advanced civilizations, where are their radio signals? With that many advanced civilizations existing in the galaxy for close to 13.2 billion years, our galaxy should have an abundance of radio signals. In close to 50 years of searching, the most we've found is the WOW signal, which is not much in the way of evidence for intelligent life. This has caused many astronomers to conclude that life in and of itself may be common, but intelligent life, while it is out there, is extremely rare in spite of the high statistical probability it exists.